All right, hey Angel, I'm Claire. This is section 9-1, circles and circumference. Angel, I think, because I won't see you for like, I don't know, however long, I am taking a bunch of your stuff and I am going to give it to your mom when I go pick up kids at daycare. So I'll give you your notes, and I know she's going to be really mad, like, why did you have to do that? Anyway, so your mom will have these, or not your mom, Rachel will have these notes and stuff for you at her house. Claire, I don't know. Maybe I'll give you your stuff tomorrow if she's going to be back. I don't know. Anyway, so we'll get to your stuff sometime. But I know that for sure Angel's going to be gone like the rest of the week, like track tomorrow, all that good stuff. So I will give you your stuff. 9-1 circles and circumference. This is like a packet. It's like a stable page, but it's really, really super quick. So circles, let's talk about like, I really kind of like their definition of a circle. It says a circle is a locus or set of all points. It's a set of points that are equidistant from a given point, which is called the center, which is kind of an interesting definition of a circle. So it's saying like, this is the center, and a circle is just the collection of all the points that are the same distance from that center, which is kind of interesting. It's like these dots make up like a line that is a circle, which I think is kind of interesting. The way that you name a circle, and you'll be asked to name it on some of your homework assignments, you will either call it circle C, you'll write out like the word circle C, or you can use a symbol. It's like a circle with a dot in the center of it, and that's circle C. It's named by what the center is called. Right? So like circle C, whatever. Don't just call it C because a C is just a dot, right? You have to say circle C, okay? All right, let's go down to some vocabulary stuff. And they have three things for us. They have a radius, they have diameter, and then they have what's called a chord, okay? So we're going to list these off to the side over here. I'm just going to look at the picture. Don't cheat by looking over. Radius. How many radii, which is the plural of radius, how many radii are in that circle? Three, technically, yeah. What's the name of one of them? DC. So I don't know if it's proper to do it this way, but I always name a radius starting from the center and going out. Does that make sense? So like I would name it like CF is one radius, and then CD is another radius, and CE is the third one. So there's technically three of them in there. Okay. Diameter. How many diameters do they have? Diameters all the way across. There's only one, and it is called DE. DE or ED, you could flip that around. Okay, that's the diameter. And then we have what's called a chord, and the definition of a chord just goes from one end of the circle to the other. Okay, how many chords are there? Is the diameter a chord? Yes, technically. If it goes from one end of the circle to the other, it is technically a chord. So there are two chords there. AB is a chord, and DE is a chord. And I'm going to put a little star by DE because DE is a special type of chord, which is the diameter. The definition of a diameter is a chord that goes through the center, right? Like this is just a chord that's going through the center of the circle, okay? That's all that a diameter has to have, okay? The diameter is the longest distance from one end of the circle to the other, right? Okay, versus like a chord is just like part of, like a regular chord is just part of that. Okay, so those are my three main pieces. What's the relationship between a radius and diameter? Radius is half the diameter, or diameter is double the radius, right? We know that, right? Okay, all right, let's go answer some questions. So here's some naming things. Example 1, name the circle. What's the circle's name? Circle P. So you can either write CIRCLEP, or you can write circle.P. Like that. Either way you want to name it, that's his name. And then identify, it says a radius. So technically you only have to label one. On your homework assignment, you will only have to label one. We're going to label all of them on the notes, just so that you're clear. How many radii does this thing have? Three, technically. Give me one. PL? PN? PM. On your homework assignment, you'll only have to list one. Okay, but here we're just going to list all of them just because it's not that much work. Okay, so that's example 1. Good? Example 2, okay, identify a chord and a diameter of the circle. How many chords are on here? 2. Is EF a chord, this guy right here? No, because it has to go from one end of the circle to the other. This one starts at one end of the circle, but it doesn't go all the way to the other end, right? Okay, so JK is a chord, and HG is a chord. I'm going to put a star by HG because HG is a special type of chord, which is the diameter. Okay, there is only one diameter here. What is EF then? The radius, right? Okay, so there's how that works. Good? Happy with that? This is just naming things, right? Okay, the next box is talking about how a radius is half of a diameter, or a diameter is double the radius. Okay, so diameter formula is 2 times the radius. Let's go down here, and they're saying that QV is 8 inches, and they want to know what the diameter is. QV is just the radius, so what will the diameter be? Yeah, 16 inches. That's it. Super easy. 16 inches is the diameter. Good? Happy with that? Yep, that's it. Okay, let's go to the back side. Let's actually do some, nope, not yet. Not computations yet. Circle pairs. I think that this is kind of interesting for circle pairs. So when we're talking about two circles existing together, we can have something called concentric circles. I'm going to break down the word concentric. So what's the word co mean? Like co-captain or co-president or whatever. Together, that's what the first period class says. Together, I'm gonna say, instead of together, I'm gonna say same, right? You're together, you're the same. You are, like, if you're co-presidents, you're doing the same job, right? So I'm gonna say same, and that's the co or con. And then centric. What does centric mean? Same center, right? Okay, so circles that are concentric circles are circles that have the same center, like the diagram that they have down below. Okay, each one of these circles, there's two circles right here, and they each have the same center, and that is center A, right? Like they each are centered at A. I know that's a squeaky chair. Centered at A. When do you see concentric circles? Like in real life. What? A target, yeah, exactly, like I have a target back there.
Turtle races and we have 2 rings.
Yeah, exactly, turtle races, yeah, like you're doing, you put the rings or whatever, and whoever reaches the outer ring. Like dropping a rock in a pond, right? Like concentric circles, it like ripples out, okay? So that's an example of concentric circles. So you might see that from time to time throughout this chapter. We can have two circles intersecting each other, and they can intersect at 2 places. So if I have the circles overlapping, they can touch here and here, or touch here and here, okay? I can have circles that are just touching at one place, in which case they're like 2 bubbles that are like touching right at the edge, or maybe one of the bubbles is inside of the other and they're touching just at that one point, right? Like it's just butt up right against each other. Or it can have circles that touch at no points, where the 2 bubbles are just out in space, or one of them is inside the other and they're concentric, meaning they're not intersecting at all. Okay, question. Can you have 2 circles that intersect at 3 places? Can they touch it just 3 places?
Well,
I had
the same circle.
Okay, so that's what Kyle said this morning, and he's like, well, if they're exactly the same circle, and I'm like, yes, I buy that, except if they're exactly, so if the 2 circles are on top of each other, they're not just touching at 3 places, they're touching at like infinitely places. Does that make sense? Okay, so you can have that happen. Can you have a circle touch at just 3 places? I don't remember who it was. It might have been Chase this morning. He was like trying to do it, and he's like, well, if it does like this, and I'm like, nice try, kid. Nice try.
Interesting circle.
That's not going to be a circle in the middle. So you can only have options for 2 circles intersecting. 2 points of intersection, 1 point of intersection, no points of intersection, or infinite points of intersection, in which case the circles are the same, right? So those are the only options I can have. I can't have just 3 points of intersection, etc., right? I have to have one of those 4 options, okay? Example 3, these get kind of messy. These are going to be the ones that like you screw up on the homework assignment, if you do, right? Like these are going to be kind of messy, okay? So I'm going to try to label as clear as possible. It says the diameter of circle S, which is the right one, is 30 units, okay? So when they say diameter, they're going end to end through the center, right? So here's this guy here, and C is the end point there. Do you see where that's located? That's 30 units. Okay, this gets kind of messy as we start to label. So from C to the other side, do you see where that is? Some people like look at D and they're like, that's kind of weird. Okay, that's 30. Now, if that is 30, I'm going to also label this, and I'm going to say from here to here is 15, and from here to here is 15. This gets kind of messy when we're labeling. Do you see why we have 15 and 15? Mm-hmm. Those are the radius lengths. Okay, now they give me another piece of information, and they say the diameter of circle R is 20. Okay, now diameter goes from end to end, so that would be like this whole thing is 20, right? But they don't even have like the whole diameter of circle R labeled. They only have like this little chunk right here. Like what is it from R to D then?
10.
10. That would be 10, okay? They give me that from D to S. Is that 9?
Yeah.
From D to S? DS is 9. And they say find CD, which is this little chunk right here. So you see how messy this gets as you're labeling? Okay. Woo! Okay. So how far is it from C to D? This little chunk right here. This is 9. And then we have like all of our other labels. How far is this?
Wouldn't it just be 15 minus 9?
Yeah, 15 minus 9.
You're so
Right? Because 15 is just from here to here, right?
Mm-hmm.
So this is 15. If this is 9, then this would be
6.
6. Now, sometimes they'll go one step further and they won't ask you for this one, but they'll ask you for this one instead. How do you solve for that? You find this one first, which is 6.
And
Then what would this be?
4.
This would be 4, right? Okay, so if they're asking for that, then you would just subtract from 10. So they said that this is 6, and then like on your homework assignment, they're probably going to ask you for this little bit. Well, we know that this whole thing is 10, and if this is 6, then this would be 4, okay? So just be careful. They might ask you for other little bits and pieces. For right now, they're just asking you for C to D, so that one is just 6 units, okay? But it can get kind of messy. Like, look at all my labels there. Like, that's kind of messy. So just be clear with your labels. Make sure that if they give you diameter, you're labeling it as the diameter, not labeling it as the radius, okay? That type of stuff. There you go, okay? All right, there's not going to be very many formulas from here on out that I'm going to make you memorize. This is one of them, though, that you will need to memorize if you have not already done so. And it is circumference of a circle. We have 2 formulas for circumference. It is diameter times pi, or 2 times pi times the radius. Now, why do we have 2 formulas for it?
Well, the radius is equal.
The diameter, yeah, the diameter is equal to 2 times r. So that's why they do 2 pi r or the diameter. It just depends on what you're given to start with, okay? So that's a formula that you need to memorize. Now, I have people all the time that screw this up with this formula. Because I have 2 pi r or pi r squared, right? Pi r squared is area. How can we remember that pi r squared is area and not? Yeah, area is always square, right? Like square feet or square inches, right? So if we are squaring something, we don't do that for circumference. We do that only for area. Area is units squared, okay? So if you're thinking pi r square, square is going to be area because area is 2-dimensional, right? Circumference is just 2 pi r. So those are very similar formulas, but the square one is the area, okay? We're not doing area today, but I just want to address that because that's what people get confused all the time. 2 pi r is the one that we want, okay? In 2005, Roger Federer and Andre Agassi played tennis on the helipad of the Burj Al Arab Hotel in the United Arab Emirates. The helipad has a diameter of 79 feet. I'm going to go across from one end to the other. I'm going to say that's 79 feet. 79 feet. And this helipad is 700 feet high in the air. Okay, they're asking us to find the circumference. Okay, so how do we find the circumference? The diameter times pi. Okay, what's the diameter? 79 times pi. What about the 700? We don't need it. They're just giving us information that we don't need. So we're trying to find circumference, 79 pi. Now, on your calculator, you should have a pi button. Don't use 3.14 because it will be rounded and it will be wrong. You should have a pi button located always when you're doing computations with pi going forward. Use the pi button and not 3.14. What do you got? 248.2. 248.2 will do just 1 decimal place, and that is feet. Okay, that is circumference. Now, what does that mean? Like, what is circumference? Like, what is it even like on this circle? What did we just find? Yeah, it's like the distance around. So I don't know if you guys can see, but it kind of looks like there's a sidewalk and then there's a railing so you don't fall off the edge of it. That would be really unfortunate, right? But they're talking about like the distance around would be 248 feet, right? So according, like from one end to the other is 79, then we can figure out like what the walking path distance would be around the edge. That's what circumference does. Okay, good? All right, now they're going to go backwards on us. And example 5, these are the fun ones. Find the diameter and the radius. So those are the things that we don't know. We don't know diameter, we don't know radius. But they're giving us that the circumference is 106.4. Ooh, we're going to have to work backwards. They're giving us the answer, and now we have to work backwards to the diameter. So I know that circumference is the diameter times pi. But they're telling me that that is 106.4. Okay? So I'm going to just use this information, and we're solving for d. To try to get d by itself, yeah, divide by pi. Is that what you said? Yeah? So the diameter is 106.4 divided by pi. 33.9, and that is in millimeters. Okay, that's what the diameter is. So we found diameter by working backwards. We're dividing by pi instead of multiplying by pi. Now how do I find the radius? Divide by 2, and that is 16.9 millimeters. Something like that. That's what it rounds to. Okay, so it's just working backwards. You're dividing by pi rather than multiplying by pi. Okay, good? Happy with that? I mean, like, this is all stuff that I think you probably did in like 7th grade math maybe or something, right?
We did this like 7th grade math.
Oh.
Yeah, we did. We did this in elementary though.
Yeah, in elementary, yeah.
Remember Lady Di? Yeah, Lady Di.
What? Lady what?
Lady Di and
And
Sir Radius.
her son is half her height.
Yeah.
Her son Radius is half of Lady Di's height.
It was a book.
We had her read a book on
Oh, very nice. Interesting.
I didn't
Well, hey. Very nice. Okay. All right, this next concept has two vocabulary words that might be a little bit foreign to you, okay? So you have the words inscribed, which means inside, and you have the word circumscribed. I know what you're thinking. It's not that word. It's not that word, okay? You're thinking of the word circumcised. I'm going to go ahead and say it. That's not the same word, okay? Circumscribed means on the outside. That's just, they're very similar to each other, but you would be, it's very funny how red a person's, like a sophomore, face gets when they accidentally say circumcised instead of circumscribed, and I have had that happen before, and it's very red, like this sheet of paper, right? That's how red your face gets. So if you accidentally say the wrong thing, just know that your face is going to become this color. It's okay. It's going to be fine.
I just know that Angela would be watching this video, like laughing as you're saying that.
Yeah.
We were doing a paper.
Angel's laughing right now. Angel, are you laughing right now?
We were doing a paper on this, and instead of writing that, she wrote circumcised on the paper.
Oh, yeah.
That's what I
Oh.
was thinking of, and then all of a sudden she stops and looks up, and I'm like, no, I can't.
Yep.
I was holding
So.
it, and I look over at Jalen, she's just running.
So circumscribed is the word, and that just means on the outside. Okay, so they give us a figure here, and they're talking about inscribed versus circumscribed. Okay, so those terms you use depending on which object you're talking about. So the circle is on the outside, right?
Mm-hmm.
Circle's on the outside. So it is circumscribed around the quadrilateral. Okay, that's not a square inside of there, obviously, but it's a quadrilateral. So so this is just saying that the circle is around the outside of the quadrilateral. But then if I talk about the quadrilateral, if I'm talking about that one, the quadrilateral is inscribed inside the square or inside the circle. Does that make sense? It just depends on which one I'm talking about. So the quadrilateral is on the inside, so it's inscribed inside the circle. But the circle, if I'm going to talk about the circle first, the circle is circumscribed around the outside. Okay? All right, so let me show you when this might happen. Let's say I have a triangle right here, and I say that a circle is circumscribed around that triangle. What's it look like? It's on the outside, right? Something like that, right? There's my circle. But let's say I have that same triangle and I say the circle is inscribed in the triangle. Then what does it look like? The circle's on the inside, right? So it just depends on what you're talking about. And you've maybe heard those words before. I know on standardized testing sometimes they'll use those words and they won't draw a picture sometimes, so you have to get that picture in your head. Inscribed is inside, circumscribed is around the outside. And if you think about like circumscribed, that CIR means outside, like around the outside, because CIR is circumference, right? Around the outside, okay? So that just depends on like what you're talking about. So let's go to this example here. A square, so they are telling me that this is a square inside of there, has a length of 9 inches and it is inscribed or inside of circle J. right? So that is a square, so each side of these is 9. And they say find the exact, circle the word exact. That means no decimals. Woo. Okay, for the circumference. Okay, so circumference is equal to diameter times pi, but the problem is we don't know the diameter. The diameter is this guy right here. Okay, how do you find the diameter? Now, the problem is, if we do that, we're going to end up with a decimal. 9 squared, like 9 squared, this is a squared, b squared, c squared, right? 9 squared, we're going to end up with a decimal. But, what type of triangle is this right here? Isosceles. It is a right triangle. So it's an isosceles right triangle, so the angles are 45, 45, 90. So what's the units for 45, 45, 90? 1 square root of 2. So if this is 9 and 9, this would be 9 square roots of 2. So my diameter is 9 square roots of 2. Do you see how that works? No decimals, right? No decimals. So diameter is 9 square roots of 2. Okay? And then my circumference would be 9 square roots of 2 pi. If I multiply that together, we're going to get a decimal. But that's not exact. So what do I do for exact circumference?
Oh my goodness. That's a good question.
Just do that.
Oh.
It's 9 square roots of 2 pi.
Oh,
That's it
okay.
for the circumference.
I thought we were gonna.
Nope, you're not. You're just going to leave it as pi, because if you multiply the pi out, then you have a decimal and you've rounded it, right? So when they say exact, that just means leave the pi in there. Okay? Good?
Are we done?
That's all. On your homework assignment, skills practice, we did odds. Really, the top half of it is just naming things, like name a radius, name a diameter, name a whatever, okay? So odds on skills practice, odds, and then evens on the other side, because I want you to do the story problem. So odds on skills practice, evens on practice. Good?
Sandy.
All right. All good?
Yeah.
Okay, bye people watching the video.